My name is Rocky Beery with Southwest Engine Academy. I'll be explaining how to use the hydraulic calculator. Where you want to start is they have two sides. One's metric, one's English. You're going to want to use the English side. As you figure out your nozzle pressure, you need to relate that with your hydraulic calculator. That's step one. So if your nozzle pressure is at 50, it says set nozzle pressure at the arrow. So you would set 50 at the arrow in the center. Step two is read discharge over nozzle bore. Okay, what this means is there on the bottom of that scroll, it's nozzle bore. You find the size tip nozzle that you have, and that'll give you your gallons per minute. You take your gallons per minute and you bump it down to the middle row of the slide. It says set flow at arrow. So whatever your flow was, your gallons per minute, you're going to put on the arrow. Read friction loss, opposite hose size. So you're going to correlate to the bottom now. What size is the hose you were using? You've set your flow. You look at the hose size now. Wherever that hose size lines up is going to be your friction loss. And that's how you use a friction loss calculator. We're going to go over a proper way to solve a hydraulics problem. The problem we're going to solve has your water source with 3 hose packs. We got to draw it out so we can follow along as we're doing this problem. Hose packs consist of 1.5 inch hose, 100 foot, and 100 foot of inch hose. I'm going to go ahead and do that all the way down the problem. So it's easier on me as I'm solving. Problem also says that our nozzle provides 20 gallons per minute, and that's for all the nozzles. And when you're drawing out problems, you should always label your nozzles and your hose, how many feet and what size. It's going to come and play later. Okay? Now we're going to start with our nozzle pressure. Anytime they give you a gallons per minute at the nozzle, 20, 40, whatever, it's going to equal 100 for the nozzle pressure. If it's a fraction of any sort, it's going to be 50 for nozzle pressure. So I have 20 gallons per minute, so I'm going to put 100 right there. The next part of our equation is our head pressure. At this point, we don't have any rise or fall, so it's going to be 0. It's on flat land. Now we're at the friction loss. This is where it starts to lose some folks. Okay? I put a 1 there because I always start with my laterals at my nozzle. Always start with the farthest lateral, or the lateral with the most demand. So right here it's 20 gallons per minute. I'm going to take my calculator, and in the middle of the calculator there's a row that asks for the flow. You set 20 on the middle row, and it's 1 inch hose, so you correlate that with the number below it. Look at 1 inch hose, and it's shown on 10. So my friction loss for 1 inch hose with 20 gallons per minute going through it is 10. I'm going to go ahead and put that right there. Okay, so I'm done with that hose. I like to mark it off so I know where I'm at in my problem. I'm at this junction right here, so I'm solving for the 1.5 inches now. Still at 20 gallons per minute. So I take my slide rule, and it's already on 20 gallons per minute. So I'm going to look at 1.5 inches. 1.5 inches is 1.5. Now, per the literature we sent you, if it's over a whole number, then go ahead and round up to that next whole number. So it's 1.5, I'm going to go say 2. So my 1.5 inches is 2. Okay? So I've solved for this one already. So my first lateral done, my 1.5 inches done. Now I'm to this junction right here. As I work back towards my water source and I pass my laterals, I have to account for them. So at this junction, I have to provide 20 gallons of water here, 20 gallons per minute of water here. So it's 40 gallons per minute I need right here. Okay? And if I keep working my way back at this junction, it'll be 60. So I've done that one, I've done that one, this is where I'm at. Don't have to worry about that lateral. Already determined I have proper flow here, so I must have proper flow in the last two, or the previous two. So all I gotta figure out is for the 1.5 inches. So I put 40 gallons per minute in the middle of the calculator, where it asks for flow. And it's 1.5 inches. Correlate that, it's 5.5. So as I said, always round up to that next high number, or that whole number. So 1.5 inches at 40 gallons per minute is 6. So that's done. Let's mark that off. I'm to the third junction now, third and final junction. So 20, 40, 60. 60 gallons per minute is what I need. Again, putting that in the middle of the calculator, and I'm calculating for 1.5 inches. It gives me around 13, so I'm going to go 13. And mark that off. Now my problem's done. On this problem, it was only solving for one stick. If there's multiple sticks, then all you do is multiply that number by 2. But since there is not, to figure out our PDP, all we do is take our nozzle pressure, our head pressure, or our head, and our friction loss, and add them together. That gives us our PDP. So it's 131 at, and your highest gallons per minute, 60 gallons per minute. And if you use those simple steps, solving one piece at a time, taking what you know and applying it, you should be able to solve any hydraulics problem.